Okay, so problem 27 is one of the longer explanations that we've had, or longer descriptions, but I'll sum it up like this. So what we're going to do, we're going to look for functions of this form, so 10 squared plus an plus b. We're going to limit a so that it's greater than minus 1000 and less than 1000, so like the modulus of a is less than 1000, and b in the same way. And then what we're going to do, we're going to plug numbers into this function, and we want each number n equal, so like here that follow like this criteria, so n equals 0 and then up to as high as we can go, so it starts 0 and then 1 then 2. We're going to be able to plug all these numbers in and produce prime numbers. So it gives the example of this one right here. So you plug 0 into this, you get 41, which is prime. You plug 1 into this and you get 43, which is also prime. You plug 2 into this and you get 47, which is prime, and so on, so on. So it wants us to basically find another one of these with the maximum number of primes for consecutive values of n. So yeah, let's get on with that. So what we're going to do, we're going to have oops, 1 second. Here it is. Okay, so what we're going to do, we're going to have a function main. This is going to define our formula, like the n squared plus an plus b. So this is obviously going to be the bulk of our code, but we're also going to need a like a prime check function to see if numbers are prime. This is going to take in n, and it's going to return true or false. That's obviously not correct syntax. This is just me making notes, so let's just comment that out. Okay, so what we're going to do, we're going to be looping over values of a and b. So a can be, like I say, from minus 1000 to 1000, b can be the same. So we're going to say for a in range minus 1000 to 1000. I'm just going to print a because I always forget which side is inclusive in this. And we're just going to pass here so we don't get an error. Actually, I don't know, I might get an error. And then let's just call main. And 27, I think this is. Yeah, it is. Why did it expect an indent? I'm confused. Is there space there maybe? Why is there space? Why is the entire of this got space? Strange. Okay, there we go. So we got 999, so it doesn't include 1000, which is good. A does not include 1000, and it starts at minus 1000, which we don't actually want. So we're gonna have this minus 999. So now that includes all the right numbers for A. Just get back to the bottom there. Now what we're going to do is we're going to have a for A in range, and then we're going to say for B in range. And now this one has a very slightly different range. This actually includes minus 1000 and 1000 for some reason. I don't know why they're different, but they are. So this one we need to be minus 1000 to 1001. Also put space there because it looks ugly. So now we've got our values of A and B. We're going to say So we're going to need something to loop over n. So we're going to say while true. We're also going to need to define, sorry, not define, we're going to need to, like, well wait, it is defined, it's defined a variable. We're going to have to define something to keep track of the number of primes consecutively we've got. And what's the actual answer we're wanting? So the answer is the product of the coefficients a and b with a quadratic expression that produces the maximum number of primes. So basically we need to find when it produces the most primes, and then our answer is just multiplying a and b together. So we need max number of primes equals 0 to start with, and then we need a times, we'll just say a b to make primes. This is going to be 0. We'll just say it's false, actually, we don't have an answer for it. Okay, so while true in this loop, we're going to say and when it's n equals 0 here, we're going to define n. Okay, so if and then we're going to say prime check. So if we've got a prime number, and we're going to pass in for the prime number, we're going to pass in n squared. That's not how you do it, squared. Oops, n squared plus a times n plus b. So if that number there is prime, then we're going to say max number of primes plus equals 1. No, we're going to say current of primes plus equals 1, and we're going to need to make current number of primes, we'll define that right here. So current number of primes plus equals 1, else we're going to say if we haven't found a prime, if current primes is greater than the max number of primes, then we know we've got a new record, so we need to record it. So max number of primes is equal to current, and a b to make primes equals a times b. That looks ugly, let's say it like that. And then we also need to break down here to get out of this true. Well, true. Is there anything else we need to change? No. I think that's right. And then all we need to do is at the end print ab to make primes. Now this would all work if this function was defined, so let's now make this function. So I actually think I've done this before, prime number stuff, but to save people going back and having to watch other videos, I may as well just remake it. It's been pretty quick so far anyway, so let's do it. So what did I just pass? Okay, so we're going to take in n and we're going to say for how do I want to do this? So we're just going to check every number, I think. It shouldn't take too long, I can't imagine we're going to get too big numbers. We'll soon find out. So for I in range n, if n mod I is equal to 0, return false because we don't have a prime number. And if we manage to make it to the end, then we want to return true. So what this does is it just checks every single number below n. It says if n mod I is equal to 0, then we clearly don't have a prime number because some number divides it. If we manage to make it to the end without hitting a number that divides it, then we return true because it's going to be prime. I just need to change this range because obviously 1 divides every number, so we need to start at 2. So yeah, 2 to n. That should work. So just to check this, I'm going to say prime check. I'm going to say prime check 2. What will that return? Oops. Print prime check 2. So we get true for 2 because 2 is prime. So we get 25. It should be false. So we get false. Say we've got 29. This should be true. And it is. Okay, so this seems to be working. So now let's just call main. And let's see what we get. Okay, so this is taking a while. What I might do is change the prime check to do like just the odd numbers, do it like in range 3 to n, and we'll go in steps of 2. That'd like double the speed. Only thing is then 4 would technically be a prime number, so I'd have to like put a clause in for that. This seems to be taking a while, so while this runs, let's just add that in. So we're going to say 3 to n, and we're going to pass in a third argument in the range function, which I don't think we've done before. But this is basically the step size, so now we're going to go from 3 all the way up to n, steps of 2. So 3, then 5, then 7. Also we're going to say just up here, if n mod 2 is equal to 0, return false. And I'll do exactly the same as this bit down here. I'll just obviously account for 2 not being included there. This seems to be taking longer than I thought it would. Actually, I think we might have an infinite loop. No, we shouldn't have. We've got a break. What I'm going to do is every time I get a new B, I want to print A and B, and then we should be able to see like a speed sort of. So it does look like an infinite loop. Definitely an infinite loop. So why is it doing that? I know why. Because I don't ever increment n. So what I need to do is just down here is say n plus equals 1, and then run this and it should work. There we go. Wow, that's going slow. Is there any way to improve that? Is it something to do with printing out? Because printing's really slow, so let's see if that speeds it up. And what we'll do is add a if. Actually, what we'll do is print A and B, but only here, so it'll let us know every time our A changes. Okay, so we'll just print A. Yes, that's pretty slow. You can see though this probably will get the answer, but this is just way too slow. It's checking prime numbers in a really bad way. How could we improve this? So probably one of the better ways to do it is just make a list of prime numbers. So every time we check if a number is prime or not, we could add it to a list of primes or a list of non-primes, and we could just update this list as we go, and then like just reference the list. Would be even better if it was a dictionary. Because there is a limit to the size of the numbers, like within this constraint of n. So we could do something where we like populate a list with all the prime numbers up to that number, because obviously every time our A or B changes, we're having to check like all the primes again. So like this number gets really big really quick, and obviously checking all the way up if some of these numbers are actually prime then will take quite a while. Let's have a look, see how I did this before. Don't actually think I've got the code from when I've done it before. It's a shame. At least these ones are going faster. It's just the negatives are going really slow. And that answer is actually wrong. Wow. Why is that answer wrong? That doesn't make any sense. Why is it wrong? I have a feeling it might be to do with this. I think there could be a typo in the thing, but it's going to take a long time to run again. Set that off while I have a look. Let's see if we can optimize it all. So, because of the form of our equation here, you can see that when n is 0, like the first case, if n is 0, then b must be prime in order for it to pass this test. So what we're going to say is up here, if prime check of b if that comes back true, then we can continue, and if it comes back false, then, so if not prime check, then we want to, do we want to do? Then we want to continue, I think is the syntax. Do we want to continue in our loop? I might, yeah, we could do that. What else do we know? So okay, so if it has to be prime, then B's range changes hugely, because it actually has to be positive, and it has to start at 2, so that'll help a lot. So we've got n squared here, b, so I think, so when n is 1, we get 1 plus something plus a prime number, so this prime number is always going to be odd, unless it was 2. But yeah, it's not going to be 2, I'm pretty sure 2 fails, but it's always going to be odd, so to keep this whole thing odd, keeps like the possibility of it being prime, then we need these 2 to add together to be even, which means they also need to be odd. Yeah, so for this to be odd right here, we need 2 odd numbers. So A has to be odd and N has to be odd. N will be odd because N will be 1. So yeah, A has to be odd. So we can work out that A can actually go up in steps of 2, which will also speed us up. And this obviously starts at an odd number, so that's fine, that's going to work. So yeah, that should speed us up quite a lot actually. And this also gives an answer that's wrong again, somehow. Why is this returning the wrong answer? Actually, really confusing. It's very close to the right answer, it's just not quite the right answer. It's significantly faster, but it's still not as fast as I'd like it. But I'm pretty certain it's just the check function, we just need to with that. Okay, so why is this giving us a wrong answer? What I'm going to do is every time this changes, I'm going to print out oops, A, B to make prime, so I'm going to see what all the maximums are basically. And I'm going to get rid of this print, and I'm going to print the, just for curiosity, the max number of primes. Okay, so this is our false answer right here. Apparently we get like 1,000 small primes in a row. Oh no, that's the value of A, I believe. No, because we're not printing that anymore. So it is the maximum number of primes in a row, or for 1,000 primes in a row with that number. It's apparently wrong. Let me just change this number to an 8. we still get that same mistake. No, we don't. Actually, that's going to go completely wrong because these are then all even. So it ruins our earlier logic. So our prime test function must actually be wrong because for some reason it's just not returning great answers. Let's check. Print n, and then false. So I'm just going to check what sort of primes it's getting wrong. Down here. Print n and true. Ah, okay, so it's the negative numbers messing it up. Right, so what we need to do is we need to add a clause in, because obviously negative numbers can never be prime, so that's never actually an issue. So what we're going to say is if this function, right, if that is less than 0, then you simply want to break. Okay, that should help us a lot. And I can now get rid of these 3 prints. Oops. Okay, this one shouldn't be too long. Ah, okay. Yeah, because these are the products. Yeah, so we're a chain of 1, then 2, then 3, then 4, and 9 in a row, and then we find 71, and our answer there is actually right this time, so that took a hell of a lot longer than I thought it would. But yeah, just the negative numbers tripping us up. So 59,231, and the answer there, 59,231. So hopefully that helped. Made some stupid mistakes in that one, like, but let me just clean this code up. It also doesn't actually take that long to run when you add the negative clause in, as you can see right here. There we go. So, thanks for watching, and I'll see you in the next video.